So in the last videos, we were looking at standard normal distributions in particular and looking at finding areas underneath those, as well as finding z-scores when we were given the areas. Now I'm going to move away from the standard normal and just give you an example of a normal distribution. So look at this example that we've seen before of heights of adult men in the US. We know that height is a variable that is typically distributed normally. And we have some information that suggests that the average height of adult men in the US is 5'9". So that makes the average height 69 inches. We also have some information to suggest the standard deviation of heights for adult men in the US is somewhere in the vicinity of 3 inches. So we're just going to say it's 3 inches. And so suppose I gave you this question right here. Suppose I said, what proportion of adult men in the US are taller than 6 feet, are greater than 6 feet tall. 6 feet tall is the same as 72 inches. And so I'm going to show you how you're going to calculate this in the calculator, and it's really the same thing that we were doing previously, but then I want to kind of show you how the calculator, and a lot of times statisticians are looking at these things and making use of the standard normal distribution that we were just working with previously. So when we're answering this question, first of all, it says the proportion of adult men in the US that are greater than 6 feet tall. It's going to be this area right here. Remember, that's always going to forever to the right. So we need to find that area. And thinking back to the last couple of videos, we can find an area underneath a normal curve by using Normalcdf, and that's exactly what we're going to do again. And we have to enter a lower bound, an upper bound, a mean, and a standard deviation. Previously, the mean and the standard deviation was always 0 and 1, but now we have a new mean and standard deviation. So we're going to enter it just like that. We're going to enter our lower bound of 72. Our upper bound is actually going to be 10 to the 99, or as I enter it in my calculator, we say 10 raised to the 99th. And then we're going to enter the mean and the standard deviation. So the mean is 69 and the standard deviation is 3. So this is what we're going to put into the calculator. It's the exact same format that we were following before. So second vars, Normalcdf, and I've got entered 72. You could see I've got entered 10 to the 99, and then a mean of 69 and a standard deviation of 3. So this is the piece that I'm changing in this video. But the calculator is going to be able to do this, no problem. So we go down and we hit paste, and we see our answer is 0.1587. So about 16% of adult men in the US are taller than 6 feet. Now, just real briefly, I want you to know, again, the calculator is actually doing some conversions here. The calculator is looking at this and saying, okay, we're actually going to standardize things. So we're going to take the original picture and we're going to convert this into the standard normal distribution. So the standard normal distribution we know has a mean of 0 and a standard deviation of 1. And so we need to think about what this picture would be in the context of this standard normal distribution. And basically what we do is we convert all of these numbers of interest into their corresponding z-scores. So if instead of looking at these numbers, we just always think, well, how many standard deviations are all of these numbers from the mean, then that's what we can record over here. And so this is a great example because since the standard deviation is 3 inches, and you can see that the distance here is exactly 3 inches, then we know that the z-score for 72 is precisely 1. Because the gap is 3 inches, and one standard deviation is 3 inches. And so the corresponding z-score for 72 is 1, meaning 72 was 1 standard deviation away from the mean. So what's going on behind the scenes is the calculator is going to say, okay, well, let's convert this to a standard normal, and then we know on a standard normal how to find all of our areas and things like that. And so maybe based upon what we were doing previously, it would be Normalcdf 1 up to 10 to the 99 with a mean of 0 and 1. And you could see if you did this, where you put in 1 for your lower bound and 10 to the 99, and then you had 0 and 1, then our answer is going to be the exact same. And that's not a coincidence. This is actually what's going on behind the scenes in many cases, because people ultimately use the standard normal curve for determining a lot of probabilities and things related to normal distributions. So let me give you some other examples that kind of go over this, but remember, you don't have to worry about this standardizing process. You don't have to worry. There's even equations that I didn't put down originally, but the equation for converting these values into those numbers from the standard normal curve, it's just z equals x minus mu divided by sigma. This is the formula for computing z-scores. And that's all this standardizing process is doing. But you don't have to worry about that. You don't have to worry about any of this. Your process is going to be normal CDF. You're going to continue to follow the process of putting in a lower bound and upper bound, and then a new mean and a new standard deviation. Okay, so let's look at another example. So a normal population has mean 7 and standard deviation 5. Find the probability a randomly sampled value is between -2 and 10. Okay, so be consistent with a lot of these problems. Draw the picture. And so we've got a normal population, and sketch that out, and it's got a mean of 7 and the standard deviation of 5. Find the probability that a randomly sampled value is between -2 and 10. So -2 is going to be somewhere on this side, and 10 is going to be somewhere on this side. And we can kind of either estimate this a little bit or just shade the region in to kind of give yourself an idea of the type of probability or the type of area that you're expecting. Remember, probabilities and areas go completely hand in hand here. So what I was previously talking about, you don't have to worry about. You don't have to worry about the standardizing process. This is a normal curve. You're looking for the area underneath it. Our setup is going to be normal CDF, and we're going to put in the lower bound of -2, the upper bound of 10, and then we'll enter the mean and the standard deviation. So the nice thing with the calculator is it handles that standardizing process. So even if the calculator is converting things to the standard normal, you don't have to. But I did want you to be aware of that. So we say second vars, we go into normal CDF, lower bound of -2, upper bound of 10, mean of 7, standard deviation of 5. An answer seems to be fairly consistent with my rough sketch of 0.6898. Okay? So we were trying to find a probability. A probability is the same thing as finding an area, and we use normal CDF. In contrast, in this example, I'm saying a population has a mean and a standard deviation, and I'm asking for the 80th percentile. And so what I'm actually doing here is this. Let me sketch it out in a picture. I'm actually saying mean is 53, and sigma, or the standard deviation, is 34, but I'm saying find the value that has 80% of the population below it. So the 80th percentile is going to be out here. We don't know what that is. That's what we're looking for. We're looking for the value such that it is higher than 80% of the population, such that the area to the left is 0.8. So whenever you're given a percentile in a question, a percentile is essentially, or at least in a normal distribution, the area to the left. It's really important to know. So whenever you're seeing a percentile, they're giving you the area and asking for a value, hence inverse norm. So we're going to use inverse norm, and it's going to be area to the left, so that would be 0.8, or our percentile value, and then we can just put in the mean and the standard deviation, we don't need to worry about any converting. The calculator is taking complete care of that. So we say second vars, number 3 into inverse norm, put in our percentile, the mean is 53, and the standard deviation is 34. Answer is 81.6151. And again, this makes sense considering that the mean was at 53, so we were expecting a number that was going to be a little bit bigger than 53. So this is just another way to emphasize the fact that normal CDF is for finding areas and probabilities, and inverse norm is for finding z-scores and percentiles. So refer to this example as you're completing your work in Connect.